Objective 2. Perform residual analysis on a regression model. Recall that a residual is the difference between the observed value of y and the predicted value y hat. Residuals play an important role in determining the adequacy of a linear model. We will analyze residuals for the following purposes. Is a linear model appropriate? We want to learn how to use residuals to determine whether a linear model is appropriate. Again, residuals play an important role in determining the adequacy of the linear model. In fact, residuals can be used for the following purposes. To determine whether a linear model is appropriate to describe the relation between the predictor, the explanatory, and response variables. To determine whether the variance of the residuals is constant, and to check for outliers. Now remember, the word residual means error. So when we do residual analysis, we are essentially analyzing the errors in our regression model. Here are three things that we are going to be using residuals for. One is to determine whether or not a linear model is in fact appropriate to describe the relation between the predictor or explanatory and response variables. It turns out that you could have an extremely high linear correlation between two variables, yet the two variables are not, in fact, linear related. The residuals will help us to identify when that happens. Number two is to determine whether the variance of the residuals is constant. This isn't a big deal when you're describing the relation between two variables, but if you're going to start making inferences, meaning generalizing your results to the population, this becomes a bigger issue. And finally, to check for outliers. We know what outliers represent now. Those are simply extreme values. So an outlier here would be an unusual value of y with a corresponding value of x, the explanatory variable. So a residual plot. A residual plot is a scatter plot where the explanatory variable is plotted on the horizontal axis and the corresponding residual is on the vertical axis. Now, so let's start by drawing residual plots. One type of residual plot will be a plot with the explanatory variable or predicted variable on the horizontal axis and the corresponding residual on the vertical axis. If this plot shows a discernible pattern, then that would mean that the linear model is not appropriate. So I'll show you what I mean by discernible pattern. But basically what should happen is the residual should appear in a haphazard or random fashion in the plot. If it doesn't appear random, then it might be the linear model is not appropriate. So let's take a look at this residual plot on the left. Okay, you can see that here's the residuals on the vertical axis. Okay, there are your values. And if you look at this residual plot, this represents a linear model that's appropriate. Now over here to your right, if you take a look at the residual plot, okay, this is a linear model where it's not appropriate because the pattern, you can see the pattern of the residuals is not in a right kind of way. In this case, it's a discernible pattern here, which is a haphazard or a random fashion. Now, so again, on the left, we have an example of a residual plot that shows no pattern whatsoever, whereas do you see a pattern in the residual plot on the right? Well, what type of pattern do you see? Well, on the right, we see a U pattern shape. So this is a U pattern shape. So the residual plot on the right shows a pattern in the residuals that tells you that the linear model is not appropriate. And why is that? Because for smaller values of the explanatory variable, the residuals are positive. And remember, a residual is defined as the observed value of y minus the predicted value of y. Now, if a residual is positive, that means that what we're observing is greater than what we are predicting. So here, in the smaller values of the explanatory variables, we're guessing, if you will, too low. Then in the middle range, we're guessing too high. And then at the larger values of the explanatory variable, we're once again guessing too low. Now, if you have this type of pattern, if you have pattern residuals, this is basically telling you that you're leaving some information on a table. So if you know for the smaller values of x that you're constantly predicting too low and for the middle values of x you're predicting too high, and for larger values of x you're once again predicting too low, wouldn't you, knowing that, make an adjustment? So that's what I mean when I say you're leaving information on the table. You should incorporate this information into your model, which is why the model that you chose, your linear model in this case here, is not appropriate. Let's talk about the variance. Now, is the variance of the residuals constant? Now, learn how to use residuals to determine whether the spread of the residuals is constant. Now, if a plot of the residuals against the explanatory variable shows the spread of the residuals increasing or decreasing as the explanatory variable increases, then a strict requirement of the linear model is violated. This requirement is called constant error variance. And the statistical term for constant error variance is homoscedasticity. Now, another use of the residential class is to see whether or not the residuals show an increase or decrease in spread as the value of the explanatory variable increases. If the residuals show an increase or decrease in spread as the explanatory variable increases, then we are violating a requirement of the linear model. This requirement, if you want to use the fancy term, is called the homoscedasticity. Homoscedasticity means constant error variance. This requirement is not as big of a deal if all you're doing is using a regression line for descriptive issues. This becomes a bigger problem when you're talking about making inference, generalizing your prediction to the population. The reason that it's a big deal is the following. The graphic on the left shows our scatter diagram with an explanatory variable and a corresponding response variable. What you notice in the scatter diagram is that for smaller values of x, the data is more tightly bunched around the regression line than it is for larger values of x. This spread in the value of the response variable becomes more apparent when you look at the residual plot. So for smaller values of the explanatory variable, if you look on the right, the residuals are pretty tightly bunched around residual of 0. But for larger values of x, they're much more spread out. The reason that this is a big issue is the fact that if you are predicting, do you feel better about your predictions for small values of the explanatory variable or larger values of the explanatory variable? Smaller, because you know that the data is pretty tight around the least squares regression line. Whereas down here, the data is so spread out over here on the right. So the variability of y is so large that we might not feel as confident in our predictions. We want to have constant confidence in our predictions for all values of the explanatory variable. Next, are there any outliers? Okay. If we're looking at the bottom here, we're going to learn how to use residuals to determine whether there are any outliers. We will follow the practice of removing outliers only if they are the result of an error in recording, a miscalculation, or some other obvious blunder in the data collection process, such as the observation not being from the population under study. Now, a plot of residuals against the explanatory variable may also reveal outliers. These values will be easy to identify because the residual will lie far from the rest of the plot. Finally, a residual plot may show outliers. You can identify the outliers quite easily because you'll see that the residual sticks out from the rest of the observations when you draw the residual plot. And even if you don't see the residual sticking out in the residual plot, another thing that you could do is draw a box plot of the residuals. And because box plots do what? Box plots show you the outlier, and so if the outlier shows up in the box plot, it's pretty straightforward to identify it. So here's a scatter diagram, and you can see that this particular observation is sticking out from the rest here. Okay? And so what you also see is the following. Okay? That's your outlier up here. Now, but they don't always show up that obvious in an actual scatter diagram. When you draw the residual plot, which is in the middle, you can see the outliers sticking out as well. And then in the last one, in the box plot, the outliers are clearly here. You can see that. So the box plot is certainly the best tool for saying for certain you have an outlier. From this graph, it's more of a conjecture, a feeling. It's rather subjective. Box plots are very objective. It either is or it isn't because it shows up. Okay, let's take a look at example here. So the example is telling us the following. It says graphical residual analysis. The data in the table below represent the club head speed, the distance the golf ball traveled, and the residuals, which is in column 4, for 8 swings of a golf club. Now, construct a residual plot and box plot of the residuals and comment on the appropriateness of the least squares regression model. Okay, so let's follow the instructions for the residual plots. Okay, so what we're going to do, and it says here, so if necessary, enter the explanatory variable, which is the club head speed in the first column of our data, and then the response variable, which is the distance, and therefore there you have that information. Okay, so now what we want to do is we're going to select now stat, highlight regression, and then select simple linear. So we're going to go to stat, we're going to highlight regression, and then go to simple linear. And then we're going to choose our explanatory variable, which is the club head speed, and the y variable being the distance. And then down here it says under graphs, so where you see graphs, okay, what we want is to select the residuals versus the x values. Okay, so we're going to select that because that's what we want, and then select compute. Okay, so here we can see what our information is, and then here is our graph. This is our residual. Okay, so this is what our graph looks like. Okay, so if we look down below, okay, it says a figure below shows the residual plot, and then we have that number at 0 here. So when we take a look at that residual plot, there is the residual plot. Okay, and if we go through 0, then it's going to match that residual plot here. Okay, now there is no discernible pattern in the residual plot, so a linear model in this case is appropriate. The residuals display constant error variance because the residuals are equally dispersed around the horizontal line corresponding to a residual of 0. And no outliers appear in the box plot of the residuals. So if we wanted to find the box plot of the residuals, let's go ahead and do that. We would go ahead and then we can create our information by either putting in our residual information. So we have our residuals. Okay, and let's put in our data value. So we have negative 3.8. Oops. Okay, negative 3.8. Okay, negative 3.1, 3.7, 2.0, 0.4, 2.2, 0.4, and negative 1.6. So if we wanted to graph a box plot of the residuals, right? Let's go ahead and do that here. We have our median, and then select compute. And if we take a look at that information, then we can compare that with what we have over here, and we do not see any outliers. And so therefore, that concludes that example.